Global investment in agri-food tech reached $16.2 billion in a single year. The sector is heavily funded, continuously building advanced yield predictions, soil analytics, and satellite monitoring. Yet, the deployment models for these tools heavily restrict their impact. The software generated by this investment typically arrives packaged in enterprise subscriptions, demanding between $250 and $1,400 a year. This creates a massive unserved segment. A farmer, an agronomist in the field, or a local forager needs instant agricultural intelligence. They do not have the budget for an enterprise contract, the time for a complex onboarding process, or the high-speed cloud connection required to load a heavy mobile application. This table details the scale of that exact demand. The total addressable market spans multiple independently large streams. AI in agriculture is approaching $3 billion, while the broader precision agriculture market sits comfortably above $11 billion. Both are expanding rapidly. Refining those top-line numbers reveals the serviceable user base. The U.S. alone has nearly 1.4 million farms with cellular internet access. Looking globally at agriculture-adjacent markets, India presents over 80 million potential users on Telegram, alongside tens of millions of gardeners searching for safe plant identification. Reaching these users with native iOS or Android applications fails at the infrastructure level. Many operate on rural 2G connections, where downloading a 200-megabyte app is impossible, and mid-session connectivity drops are standard. The precision agriculture industry has built billion-dollar tools, but its enterprise delivery mechanisms ignores the economic realities of the majority of global farmers. The strategy behind LeafEngines ignores the App Store entirely. It is engineered to meet users inside the platforms they already have installed on their phones. The product sits precisely at the intersection of three accelerating trends: the maturation of utility bots on mobile platforms, the explosion of the Model Context Protocol developer ecosystem, and the rising adoption of AI agronomy. Telegram currently hosts 1 billion monthly active users. It operates seamlessly in low-bandwidth environments, making it the dominant messaging platform across the Global South. Simultaneously, the Model Context Protocol, or MCP, is standardizing how AI agents access external tools, processing over 1 billion calls a month. LeafEngines builds its intelligence layer once, then pipes it directly into both of these massive pre-existing networks. This captures the unserved gap, delivering a mobile-first, zero-install agricultural advisor at a $9 consumer price point. This approach bypasses traditional customer acquisition friction. By weaponizing existing networks, LeafEngines translates agricultural capability into a pure distribution play. Delivering high-end data through a chat interface requires an architecture prioritized entirely around access and hardware independence. This matrix breaks down the current competitive landscape. Most products require significant friction to operate. Climate Field View charges enterprise pricing and lacks offline capability. John Deere ties its software to expensive machinery. Neither integrates with a frictionless platform like Telegram. LeafEngines outpaces standard apps by supporting AI agents and retaining offline capability. If connection drops, the system falls back to text templates. This backend logic is protected by 2 U.S. patents, while the MCP server is open-sourced, encouraging developers to build on it. This unified backend feeds a unique cross-section of users. AI power users query it through Claude, workflow builders plug it into automation tools, and farmers interact with it via a lightweight chat message. Creating moats through isolation and proprietary hardware is an outdated model. Defensibility is now achieved through absolute ubiquity. Freemium AI tools face a notoriously high failure rate. Providing unlimited, resource-heavy LLM queries for free rapidly depletes runway, especially when typical Telegram bots only convert between 3 and 5% of their users. This analysis outlines the math. Gemma 4 via Google AI Studio drops inference cost to a fraction of a cent, driving an 83% gross margin on the $9 Pro tier. Thus, 200 daily active users require only 30 subscriptions to break even. But the true profitability driver is the cross-platform architecture. Implementing a unified identity system allows a user to link their Telegram bot account with their desktop workflow automations. This continuity justifies a jump from the $9 individual tier to a $29 team tier. Extending the same intelligence API to a new channel incurs near zero marginal cost, but offering unmetered data across those integrated channels generates an 8x revenue multiplier. The freemium tier serves as an ultra-low-cost customer acquisition engine, deliberately driving curious users toward high-margin cross-platform subscriptions. Paying for digital ads to acquire rural users or foragers is financially inefficient. Growth requires an organic mechanism that compels users to share the tool voluntarily. The marketing strategy centers entirely on a single flagship feature: safe plant identification cross-referenced against a toxic lookalike database. If a user photographs a wild carrot, the bot returns an immediate safety warning, visually comparing their photo to poison hemlock, providing life-saving context. This creates a self-reinforcing organic growth loop. The user experiences an unexpected, high-stakes result and immediately screenshots it. They share that screenshot into large Facebook foraging communities or gardening subreddits. Viewers see the bot's handle, open Telegram, and test it with zero installation friction. The messaging isolates precise pain points. For a farmer, the bot is marketed as soil truth in your pocket. For a gardener, it is framed simply as a toxicity check with one photo. Technical users are captured through direct placement in high-intent repositories, specifically indexing the tool in the awesome MCP servers list and the N8N community forums. When a developer integrates LeafEngines into an agency workflow, the resulting automation or alert system often reaches the end client, the agronomist or extension agent. The agent then discovers the mobile Telegram interface, shifting from an enterprise end user to a direct mobile consumer. High-emotion utility drives human behavior. By consistently delivering surprising safety data without a paywall, the user base becomes the primary distribution pipeline. Execution requires strict technical discipline. The rollout roadmap begins with a Phase 0 checklist, treating API key configuration, rate logic validation, and database setup as hard prerequisites before public exposure. Scaling from 200 users up to 5,000 requires uncompromising metrics. By month 12, the system must maintain a tool call success rate over 98% and response latency under 2 seconds. If the bot is slow, users will abandon it. The internal risk register actively plans for the most dangerous prac to a freemium AI model: uncontrolled free-tier abuse, resulting in an exponential API bill. By utilizing a zero-install architecture, the platform reaches low-bandwidth users across the global south that traditional enterprise applications are simply too heavy to serve. Connecting those mobile profiles with desktop developer workflows triggers an 8x revenue multiplier, proving that cross-platform continuity drives strong unit economics. By leading with the immediate, high-stakes utility of toxic plant identification, the product bypasses paid customer acquisition entirely. This strategy identifies exactly where enterprise software is too rigid and expensive and steps into the gap with an optimized, platform-native intelligence layer.